So in this lecture, we will learn about the analysis of algorithm. So we will look at the details. And first, we will check what is pseudocode, and then what are the important functions, and then we will learn about the big O notation and the variant. Pseudocode. We call it pseudocode. Of the algorithm. Most algorithms transform input objects into output objects. So let's say if you practice with the guru, I always give you the input, and then let's say I give the input 5, and then you will need to show the output. For example, the output is 1, 2, 3, 4, 5. It means you need to do a loop. You need to do repetition. Then it means I have input and I have output. And for every problem, when you have an algorithm, it should work with different input. For example, I know that the input is 5, then the result is 1, 2, 3, 4, 5. If the input is 10, then the output is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So using one algorithm with different input, you can get different output. So your algorithm only one. So in Gurum, I will always give you two input like this one or two example, but actually you need to only make one coding. You need to make only one algorithm. And when we create the algorithm, there is a running time. Usually we will see it in the Gurum how long it will take to run the algorithm. And the running time of an algorithm typically grows with the input size. So if the input size become high, then the time also high. For example, if I have 5, maybe the time is only very short. But if you have 10 data, maybe it will be longer. So we call it the average case, average penguin. Then it means what is the average when I run my algorithm? It is often difficult to determine it because you need to run many data. You need to run many experiments. Zero money gathered. So instead of the best case, we want to focus on the worst case running. Worst case means the most the highest time performance during you do the experiment. So the best case is maybe the lowest time. The average case, maybe yeah, when you do with 5, when you do with 10, when you do with 15 data, and then you make the average. But we want to focus on the worst case because this is the most important. The worst case, if the worst case is 120 seconds, okay, then you need to have a computer at least how to solve that algorithm in 120 seconds. If we can solve it in 120 seconds, it means we can solve with the lower time. So this worst case is easier to analyze and it is crucial to applications. For example, if you play games, or if you do something like finance, or if you do some application in robotics. So you need to make it very slim. It means the time should be very good. And we want to know what is the worst case. So we have the best case, average case, worst case. And we usually look only on the worst case. So how to obtain the running time information? In order to get the running time information, we can do two things. The first, experiment, zero. So we can do a lot of experiments, and then after we have the values, we can do the analysis or theoretical analysis. Zero. So we can see only the algorithm, okay, how many times this will work, and so on. Experiment, okay, experimental studies. It means we will write a program implementing the algorithm. So we will run, how to code, and then we check the time. And then run the program with inputs of varying size and composition. So we can note the time needed to solve the problem. For example, I have this one from time, import time, and then I check when the algorithm starts, run the algorithm, and then when the algorithm stops. So we can have the start, stop. Okay, now we check how long the algorithm works. And then we will do for every input size. So for example, I have 10 data. Okay, with 10 data, the time performance is 100 milliseconds. And then check with 20 data. With the 20 data, we have maybe 800 milliseconds. Check with 30 data. With 30 data, we have about 1000 milliseconds and so on. Then we can do the plotting. When the input size is high, then the time performance is also high. That's the common sense. So at the end of this class, okay, so during in one semester, you will do this algorithm, and on the final project, you need to plot like this. So you need to design one algorithm, and then you need to do experiment, and then you need to see what is the time performance of your algorithm. Now let's see with the example in the I give you one example in this Jupyter Lab. Okay. So I give you one example. Here is a function that takes a list of input. It returns true if there are any duplicates and false otherwise. Duplicates. So it means if we have the data double, we have the data not only one, but more than one. So this is the code. I have a function duplicates, and I will make one parameter, this is L. So L, I will check the length of L, and then I will do loop from the data 0 until the length, and then check also from J equals 0 until the length. And then if I not equal to j, and if the data is the same, then we will zoom. So this is one algorithm to check the duplicate. For example, maybe I will remove this one. Okay, I will not explain that. It is one of the way to run the algorithm. Let me just use print. So print duplicates 1, 2, 6, 3, 4, 5, 6, 7, 8. Okay. Can you see any duplicates? This one? The duplicate is 6. Okay. So it is more than 1. So we call this is duplicate. And now I want to check, is there any duplicate from this data? And the result should be 2. What about this data? No duplicate. So the result should be false. And if I run this, then the result is true for the first data, and then the result is false for the second data. Okay. So I also want to let you know when you do with Guru. Okay, when you do with Guru, it is different with Jupyter. In Jupyter Lab, maybe when you run this one, you will get the result 2. But when you do with Guru, you need to use print. Okay, you need to show with print. So please do the practice because it will help you to understand the Guru environment. And now let's check. The data that I give is only 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 data is small. Now, how about if I want to make 1,000 data? Okay, so I generate the data 1,000, and then let's try to do the experiment. So the experiment will be, I will check the start time, and then I will check the ending time. So it means I will check how long it will take to solve these duplicates, and I will minus or subtract with the start time. So this is the ending, and this is the start time. Then I can know how long the time taken to solve this duplicate. So if you run this, okay, to run the algorithm for 1,000 data, it took 0.05 seconds. For another 1,000, it took 0.04. For another 1,000, it took 0.04. For 1,000, 0.04. For another 1,000, 0.04. Okay. What is the best case? Best case is 0.0447. This one. This is the loss. This is the best case. What is the worst case? The worst case is the longest. What is the longest? Here, 0.05. So the longest is 0.0. What is the average? In this case, yeah, you need to do the calculation 0.05 plus 0.04 plus 0.04, 0.04, and then you will divide with 5. Okay. Then that is the average time. That's why we just say that let's use the worst case because it will determine whether your algorithm is good or not depending on the computer. So we will just use the worst case, not the average, not the best case. And whenever you do the experiment, you can also do with different kind of ways. Okay. So for example, I have another function. So I have another function to indicate this is the function name. This is the data. And then I want to specify how many times I want to do the experiment. So at first, this is the experiment with 5 trials. 5 trials means I have the same data and it was 1000, but I want to do it 5 times. So I have 5 results and I can see what is the worst case, what is the best case, and what is the average case. Now I want to make it, maybe the trials become a value. Let's say I want to make the trial equals to 10. And then let's call the function and then let's check the number of data. So I can run. So now I have this data. If I run, you can see I have different data size with 50 data set, 100 data size, 200 data size, 400 data size, 800, 1600, and 3200. Now with 50 data, the time is this one. This is the average. With 100 data, the average is this one. With 200 data, the average is this one. With 3200 data, we have 0.4 seconds. So you can see if the number of data increase, then the time also increase. So whenever you do with the algorithm, you may have different kind of algorithm to solve the problems. Duplicates one is the algorithm. Duplicate one is the algorithm to solve this duplicate, and this is the code. And I want to know whether it is good or not compared to the algorithm duplicates 2. So duplicates 2 is different algorithm. The algorithm is like this one, n is the length, and then I have the range from 1 until n. I have the range, and then I just directly check. And then I will do checking. Okay, if you see this one, in with n 3200, the average time is 0.19. Previously, with n equals 3200, the average time is 0.47. So which algorithm is better? In terms of the time, this is slower than this one. Or I can say this algorithm is faster. Of course, whenever you do something, if you want to solve a problem, you want to get a faster algorithm. So at the end of this course, you can do the final project and then find the algorithm which can solve a better solution, or we call it a faster algorithm. So you can see the result, but the result can be seen faster than the other algorithm. So I will also give you another algorithm. For example, I use duplicate tree. Okay. So the duplicate tree is using this code. mm, This is a code, what we call as the list comprehension. List comprehension. So I want to check if Li equals to Lj for I in the range of this one and for j in the range of I. And we will check whether it is true or false. Now, let's see. Okay. With 3,200 data, the average time is 0.37. Maybe this is the second better algorithm. The first is this one, because with n 3,200, we can solve 0.19 seconds, and so on. Okay, so I also give you like the algorithm 4, algorithm 5, algorithm 6, algorithm 7, algorithm 8, and so on. So you can see one problem, we can solve it with many different algorithms. So during one semester, you will learn many things about the algorithm. So try to design your algorithm. And then at the end, you need to check whether your algorithm works faster or not, like this one. Now, the issue is when we do the experiments, it is difficult. It is necessary to implement the algorithm, which may be difficult. So we need to understand what are the external parameters. The external parameters means, let's say, uh, you cannot see the output when we have only a single input. So the restrictions are not guaranteed for all inputs. So for example, if you know the example before, we use the 1,600 and then we skip the other and then we use 3,200. But maybe when we use 2,000 data, something also we need to check, but we do not check it. So there is no guarantee for all the inputs. And performance may differ for unobserved inputs. Because whenever you design the algorithm, you will have many things about the parameters, not only single parameters. Maybe you have 5 parameters, or in the machine learning, you will have like 10 parameters, or sometimes in the deep learning, you will have like 50 parameters. So different parameters may have different results. And the other things is about your computer. In order to compare two algorithms, the same hardware and the same software environment must be used. So whenever you do later with this kind of experiments, you need to use the same computer, because different computer, it will give you different result. If I use this computer, it will give different result with the If I use this computer, of course, this might be better compared to my laptop. Maybe when you run in this computer, in this room computer, it will be better than your laptop. So the environment given will make the different result. In the theoretical analysis, we just focus on the idea. So it means we look at the algorithm steps, not the specific code. And we want to check the time as a function. We describe how long it takes based on the input size n. And then all inputs matter. It means we consider the worst case or the average case time, covering all possibilities. And we are just pure analyzing the algorithm speed. That means we want to measure how fast the algorithm itself, ignoring the computer speed or the programming language. Now you are using Python. So some people say that Python is not efficient. So when you do with big data, Python is very long to solve the problem. And sometimes people say Java is better for big data. Yeah, of course, Java is better. But with the theoretical analysis, with this theoretical analysis, we don't care with the programming language. We just care about the some theoretical ways to solve the problem. Now let's check what is suitable. So in the theoretical analysis, we will use pseudocode. Pseudocode is a kind of recipe. You know recipe? When you then you need to have a recipe. Prepare rice, prepare water, prepare the salt, and such. So pseudocode is similar to recipe. Think of it as a recipe. So it is a step-by-step guide for an algorithm. And then it is clear but not code. It means when you do with the code, it will be different with pseudocode. We need to use simple language, easier to understand than the real programming code. It focuses on the logic. So it shows what the algorithm does, not how to write the exact program. And the pseudocode should be easy to share. It means it is the standard way of people to describe and discuss the algorithm. So people should understand your pseudocode and ignores coding details. It lets us focus on the algorithm's idea without worrying about specific programming rules. For example, in Python, we focus like if A is greater than B, and we need to put column. If you don't put column, what happens? So in pseudocode, we don't care with this one. So we want to make only the logic. The logic is A is higher than B. Okay. Later on, when you put in Python, it will be different when you put in Java. So different programming language will have different problem. So in pseudocode, it should be only just the language. For example, the control flow. So I already teach you the very simple control flow in Python. For example, if, then, else. So in Python, you need to if something something in between this one, and then else if something something, and then else something something. So in the pseudocode, you don't need to care. You don't need to do this one. So you just need, if a condition is true, then what will you do? Otherwise, what will you do? We can also do something for the repetition. While if the condition is true, what will you do? And then we can have repeat. Let's do repeat until the condition is true or until the condition is false. We can do for loop. So for until the condition is false. Or indentation to replace braces. So many things that we can point, not exactly the same with Python, but just to make the logic. And we can also do some method declaration. So for example, I have the algorithm and the algorithm name is method. So the algorithm method will have some arguments. Okay, in the arguments, we have the input and we have the output. So many paper, you can see later, they use this kind of format. So what is the algorithm name? What is the input? What is the output? And then we can also look at how to call the method. Just call the method name, say this one. And then what is the return value? So if you have a method, then you have a return value. And what are the expressions? Sometimes it is not the same with the Python. So the assignment is using array. A is assigned as 5. So I want to put the value 5 into the variable A. In Python, we use A equals to 5, something like this. And in logic pseudocode, the equals is to use for the equality testing. For example, A equal to B. If A equal to B, then what happens? Or sometimes you cannot see the very exact formula. In Python, you cannot do like n power of 2. In Python, how to define n power of 2? You need to n star star 2. Okay. So this is the Python syntax to describe n power of 2. But with the pseudocode, you can just type n power of 2 because Python will have this way. But with Java, it will have different way to solve it. So this is one example about pseudocode. I have the algorithm grade. So the goal of this algorithm is to change a numerical grade to a letter grade using the following rules. So if the grade A, it means the score is higher or equal than 90. If it is the grade B, then it means the score is in between 80 and below 90. If the grade C, then otherwise. So we have the name of the algorithm is algorithm grade. And then the input is a numerical score, S. And the output is the letter. So S, if it is higher or equal to 90, then return grade. And okay, then this is one if the S is higher than 80 and S is lower than 90, then return grade B. Else, return grade C. So this is one pseudocode. If you try to write this code into Python, then what happens? This is not working because this is not Python language. This is just a logic. We call it this is pseudocode. So this should be easy to understand. This should be distributed to other people. So every people should understand this logic. If other people understand this logic, then you can try to use in Python, in Java, in C, C Sharp, C++, and etc. Okay. That's the meaning by pseudocode. So in the algorithm analysis, there are some important functions. There are 7 important functions. 7 functions that often appear in the algorithm analysis. At first, we call it constant or 1. So constant means when the amount of data is high, the time or the number of operations is always 1. So it will not change when the n is high. So when the data is 10, the number of operation or the time is 1 second. When the data becomes 10,000, the number of operation is also 1 second. So we call it this is constant. Is there any operation with this constant? Later we will learn. There are some operations that can do with this constant. The worst scenario when you deal with the algorithm is exponential. Exponential means it depends on the n. N is the number of data. So if there are 10 data, it means you will do like 2 power of 10. So the number of operation is 2 power of 10. When you have 10,000 data, it means the number of operation is 2 power of 10. So this is very, very long. So it takes very, very long to solve the problem. In between the constant and the exponential, we have many different functions. For example, we have logarithmic function, log n. So log n can be represented like this one. Linear n. So linear is the most popular one. Let's say I have the data is 10. So maybe the operation is about 5 seconds. When I have the number of data is 1000, maybe the number of operation or it takes about 500 seconds. When I have the data 100,000, then maybe this will take about 5,000 seconds. So the number of operation, it goes up along with the number of data. And the function is linear, or we call it n. Next another function, we call it n log n. So n log n, it's just like this one. And we have quadratic n power of 2, or we have also another function n cubic. I think this one is n cubic. And the this algorithm is n 2 power of n. So in a log chart, the slope of the line corresponds to the growth rate. So this is the growth rate. We call it the growth rate. So whenever you have the algorithm with the exponential, you need to reduce it. You need to make it better. You need to make it more optimum. You need to make it more efficient. So later you need to find out this algorithm analysis. So whenever we do the analysis, we need to understand the primitive operations. So primitive, maybe sometimes we call it basic operation. This is just very simple operation. We call it primitive. So this basic computation performed by an algorithm. And this is identifiable in the code. It is largely independent from the programming language. Exact definition not important. So we will see why later. And assume to take a constant amount of time in the RAM model. In the RAM means in the random access memory. Whenever you have your computer, you will always have RAM. So some example of the primitive operation like this one. If. So when we do the evaluation of an expression, this kind of if is simple, or we call it primitive. Assigning a value to a variable. So for example, a equals to 1. This is also primitive or simple operation. Indexing into an array. So they are 0. So this is also primitive. Calling method. So when we call a method like this one, check both event. So this is also primitive operation. Returning from a method. So return number. So this is also primitive operation. So we can count the primitive operation. By looking at the Python code, we can count the primitive operation line by line. For example, like this. A equals to 1. Then it is primitive operation. Because this is one operation. B equals to 5. This is another primitive operation. This is one operation. This is primitive operation, one operation. This is primitive operation, one operation, and one operation. So in total, we have 6 operations. So because we have the best operation is 6 operations. And the worst is we have 6 operations. In this case, we don't care with the number of data. Let's say if I have number of data is 1000, the operation will be still only 6. Whenever I have the data, let's say it's 100,000, the number of operation is on equal 6. So this is what we call as constant. Okay. But it will be different with this. We have one operation. This is we have 5 times. Because we have from I range until 5. So let's say n is the number of data. So if n is 5, then we call n. And then we have 2 operations here and here. Then we have 2 operations for this one until n time. And this is one operation. So at the end we have 3n plus 2. So n plus 2n, it is 3n. And 1 plus 1. So 3n plus 2. So the algorithm is approximately linear n because we are. Okay, I think I will stop here. So let's continue on Wednesday for this algorithm analysis. Any questions? Okay, thank you very much. Sudah.